Hi, welcome to the traffic light. This project is an introduction to assembly language code, and essentially what it does is it turns on the green LED for 2 seconds, the yellow for 1 second, the red for 2 seconds, and then it repeats. So here's a quick demonstration. So this would be very simple to do with high-level code. It would simply be a digital write, a delay, and a couple of digital writes. But this actually accomplishes the same task using assembly language, which is quite a bit more complicated. So let's get into how that assembly language code works. Okay, so now that we're in Microtrip Studio, I have the debugger open and we can run through how the program works. So the first line that's executed is this line here, which is load immediate LDI R16 green or yellow or red. So it's going to put green or yellow or red, which are these three defined values, into register 16. And essentially this is the bit mask of the green pin, the yellow pin, and the red pin, and it's going to put it into register 16, which is just acting as a temporary buffer, and it's called a working register. So when we run that line, register 16 is right here, and right now it has hex 00 in it. And when we run this line, we can see that hex 38 goes to it, which is the value of the bit mask. So this line is out, which sets an I/O register, in this case DDR, which is DDRB, and that's the data direction register. And what we're doing with it is we're putting the bit mask of the green, yellow, and red pins into it. And what that's going to do is that's going to set those three pins, the red pin, the green pin, the yellow pin, as outputs. So when we run that, we can see that these three bits in the DDRB register go high. So now that's the setup code that's basically run, and now we're in what's technically the loop. And the first thing we want to do is turn on the green LED. So first, we're going to put a bit mask for the green pin into register 16. So right now, register 16 has hex 38. When we run it, it has hex 20, which is 32 or 1 shifted left 5 times, which is the green bit mask. And then we're going to put that bit mask into the port. So we run that line, and we see that this pin, which is the green LED pin, bit 5, turns on. So at this point, the green LED would be on. So next we're going to check if the current shown color is yellow, because as we saw in the demonstration, the yellow pin only runs for 1 second, whereas the other two run for 2 seconds. So this is the CPI, or compare immediate instruction, and basically if the value in R16 is equal to 1 shifted left 4 times, or YELL, the Z flag is going to go high. Since we know green is in R16, we don't expect the Z flag to go high. And as we can see, the Z flag did not go high. So now when we execute this branch, it's a branch of equal, which means if the Z flag is high. And since the Z flag is not high, ordinarily we go to the next line, which is to delay 1 second. But that line is commented out because it interferes with the debugger. So when we execute this, it'll go to the next available line, which is LSR R16, and that's a logical shift right of register 16. And the reason it does this is because the yellow and red pins are the green pin shifted left right once and twice respectively. So essentially the way it works is it just shifts the bit mask down 1 pin at a time, and then that cycles through the colors. So green, yellow, red, green, yellow, red. So next it does another compare immediate statement, and it's just checking if the bit has overflowed. So if it goes out of the bounds of these 3 pins, so to bit 2, which is not a valid LED, in this case, it will set the Z flag. So right now it has not overflowed, so we don't expect the Z flag to get set. So when we do this line, branch of equal reset, we don't expect it to branch because the Z flag is not set. So it should go to this next line, rjump run. And it does. So this sets it back to the run flag, which just loops through another iteration, which in this case is the yellow iteration. So right now it sets yellow into port B, and we'll just go through this iteration until it's red. So now we have the red LED on. So when we go back to the compare immediate, when we execute this line, it should set the Z flag. So we're going to execute this line, and we see it has set the Z flag. So now this branch of equal will also execute. So when we execute the line, instead of jumping to run, it jumps to reset, which puts the green bit mask back into R16. So when we run this, again we see hex 20 into R16. So this just repeats again and again. So it goes green for 2 seconds, yellow for 1 second, and red for 2 seconds again. So yeah, that's how the traffic light works in assembly. Thank you so much for watching. I hope you learned something about assembly language.